Today we are going to see how to design an LED blinking program using Arduino board in an online simulator known as TinkerCad.com. So first of all, you can click on TinkerCad. You can type TinkerCad in the Google. Then you will be getting a TinkerCad site. You can click on that. Basically, the TinkerCad is used for designing 3D models so that it can be printed on a 3D printer, as well as it is used for designing electronic circuits and simulate it. So when you are clicking on the TinkerCad.com, by default it will be taking to a page where 3D designs done by me is shown. But for time being, I am going to design some electronic circuits using TinkerCad. So for that, you can click on this Circuits tab on the left hand side of this TinkerCad.com. So now you can see all the circuits that I have designed using this TinkerCad in this window. Now I am going to create a new circuit using TinkerCad. So you can click on this Create a New Circuit button. So a new workspace will be available for you, and I can create my circuit there and simulate it. So here you can see by default the basic components available in TinkerCad is shown on the right hand side. You can see the resistor, LED, switch, battery, Arduino, motors, etc. And there are few more other components available in TinkerCad for our utilization. So if you want to see that, you can click on this drop down, select all. So all the components available in the TinkerCad is shown here. So for time being, I am clicking on the basic components list, and first of all I am going to add the Arduino Uno to my workspace. So how will I add that? Simply click on this and drag it to my workspace. So you can see I have added the Arduino Uno here, right? So next step, what you need to do? You need to write a small program for blinking of the on-board LED present in this Arduino board. So here you can see one L is written. This is the onboard LED which is already connected to the Arduino Uno board. So in the Arduino Uno board, you can see that this is a controller or microcontroller used in Arduino. So this IC is ATmega8 or ATmega328 based on which board you have purchased. And you can see that in the Arduino board there are certain digital pins. Digital pins are starting from 0 to 13, so that these pins can be used for digital input as well as digital output. And on the other side, you can see there are certain analog pins which are named as A0 to A5. That means 6 channel analog input pins are there. That means you can connect the analog input here, and the controller can convert it into digital format, and you can use it in the program. So analog pins are used for giving analog input to the microcontroller. Digital pins are used for giving digital input to the microcontroller. So what do you mean by digital input and digital output? If you want to say make an LED blinking program, in that case LED should be blinking say infinitely. That means for making the LED on, you need to write digital 1 to the LED. For making the LED off, you need to write digital 0 to the LED. Right. So for those purpose, you can use this digital pin. Similarly, these digital pin also can be used for taking digital input from the external world. How will you give the input from the external world to the controller? Digitally, the basic digital device is a switch, a push button switch. You can connect a switch. When you are pressing a switch, whatever external signal you are giving to the switch will be given to the controller, right? And that signal can be either digital 1 or digital 0. So for digital input as well as digital output, you will be using these digital pins. Then you can see another set of pins known as power pins. So these pins are used for providing 5 volt supply as well as 3 volt supply. In addition to that, 2 grounds are also there. So if you want to connect a small motor which is working on 5 volt, you can take the supply from this pin. If you want to connect another device which is working on 3.3 volt, you can connect it from this pin. Then the corresponding grounds are here. You can use any one of the ground pins. On the other hand also you can see one ground pin. So this is a basic Arduino board, and you can see that there is an on board LED which is represented as this L. This is internally connected to pin number 13. So if you want to make this LED on, you need to write digital 1 to pin number 13. So now we are going to write a small program for blinking of onboard LED using TinkerCad IDE, and for time being we will be using block programming or visual programming. So first of all, you can click on this code button. You can click on code. So now you can see so many blocks are available here. There are certain blocks related to output. So you can see set built-in LED high, set pin 0 to high, like that few blocks you can see. Similarly, if you are clicking on the input block set, you can see certain input blocks. Say read digital pin 0, read analog pin 0, like that. Then certain control blocks are there. So here you can see the wait statement, which is used for creating a delay. Then if then else block you can see, if else block you can see, like that all the control blocks are available here. Then math block is there. Here you can see all the blocks related to the mathematical operations. Finally you can see variables block. So whichever variable if you have created, it will be displayed here. So now by default we will be in output block window, and when you are opening the code window itself, automatically the LED blinking code has been displayed here. So how will you switch on this LED, or how will you perform the LED blinking program? First of all, you need to switch the LED on, then you need to switch it off, right? This process if you are continuously doing, you can see the LED blinking. But here the problem is that the Arduino microcontroller, it is working on say 12 megahertz crystal oscillator, or say in our case it is 16 megahertz crystal oscillator. That means the time taken for execution of one instruction will be 1 by 16 megahertz, right? 1 by frequency will be the time period. So each instruction will be executed in one cycle or one time period. So how will you calculate the time period? 1 by frequency. So 1 by 16 megahertz, that is point something microsecond you will be getting. That means each instruction will be executed in point something microsecond. So what I have done before, I am making LED on. So LED will be on for say point something microsecond. In the next statement, I am switching it off. So in the next point 0 something microsecond, LED will be off, right? So LED on state and off state will be very fast, or it will be executed in few microsecond or less than 1 microsecond, because it is point something microsecond. So what problem will be there? I will not be able to see the blinking of the LED because both the states are very short. So if I want to see something with my eyes, each state should stay in my eyes for at least half a second. But here for point something microsecond only it will be on. Then point something microsecond it will be off. So if I want to see the LED on state, LED should be on for at least 500 millisecond or half a second, right? So what should I do? I need to make the LED on, then I should give some delay. If you are writing a program in C or whichever language, how will you create a delay? You will be using a for loop or whatever loop it is, and you will be using a variable. You will start counting the variable from 0 to a maximum value in the program. Simply you will start counting from 0, 1, 2, 3, etc. up to a value. So that time taken for counting will be taken as a delay. This is how you are creating a delay, right? So here what you should do, the same method you need to use here. So you need to make the LED on, you need to create a delay, or you need to wait for some time. so that I can see the on state. Wait for at least say half a second or 1 second. So I can see the on state. Then I should make the LED off. Again wait for some time so that I can see the off state. So if both on state and off state is kept in my eyes or in the eyesight for at least half a second, then only I can visualize the blinking effect. Right. So that is what we are going to do. So first of all, what should be done? You need to make the LED on. How will you make the LED on? Say in the output block set, you can see a block known as set built-in LED to high. So I have dragged and dropped here. So already the LED blinking program is there. So now I am going to show how this is created. So first of all, I am dragging and dropping this block. So set built-in LED to high. That means LED will be on. Then what I told, you need to give some delay so that I can see the on state. How will I do that? You need to click on control block set. Here you can see wait block. So drag and drop that wait block. So initially it will be waiting for 1 second. If you want to change the second to millisecond, you can give here. For time being, I am selecting 1 second, 1 second. Then what should I do? I need to make the LED off. How will I make the LED off? Again click on output block. Take the same block, set built-in LED to high. Then what should I do? Click on this high, that drop down menu, select it to low. So you are setting the LED built-in LED to low. That means LED will be off. So I need to see the off state also for some time. So what should I do? Again I need to take the wait state. How will I take the wait state? Click on control, drag and drop the wait state. 1 second. So LED will be on, it will wait for 1 second. LED will be off, again it will wait for 1 second. So this process will be continuously executed. Right, this process will be continuously executed. So this is how you are writing or building an LED blinking program using Arduino IDE. So for time being, whatever I have created, I am deleting it because I need only one program, one set of blocks should be there. Then only this will be running infinitely. Whatever I have designed, I have deleted. You can drag and send it to this bin. So you can drag it and keep it here. It will be deleted. So now what I am going to do is I am going to run the simulation. How will you run the simulation? You can click on this stop simulation button. So when you are running this, you can see that your LED is blinking here. Can you see the LED with the label L is blinking infinitely. So this is how you are executing or simulating an LED blinking block set using Arduino. So for stopping the simulation, you can click on this stop button.